Hey, what's up, everyone, and welcome back to another uncut, unedited Mr. Oldenburg math video. Today we're talking about dividing whole numbers and unit fractions. So all week we've been talking about doing one and then the other, vice versa. Today we don't know which way we're going to get it, which means we need to do one major thing. Pay attention to what the question's asking. Because again, like I said in every single video of this unit, if we don't pay attention to how to set it up, it's wrong from the get-go. So let's remember one thing. First of all, I don't have my stylus with me today. Not very good. But the other important thing, when we're dividing, it's always what we have divided by how it's cut or shared. Okay? Biggest point we need to remember whenever we're reading a problem. So today it says the Brown family is planting 1/3 of their garden with flowers, 1/3 with berries, and 1/3 with vegetables. Before I even start, the only thing I'm concerned with is drawing a whole garden, because we're always starting with a whole when we're talking about units, all right? The vegetable section has equal parts of carrots, onions, peppers, and tomatoes. So first of all, equal is letting me know that I'm going to divide, and it also makes sure that I know that each value is going to be the same, so I can divide. The other thing I forgot to do was it said that each part was in thirds, a third with flowers, a third with berries, and a third with vegetables. I don't know who makes their garden like this. It's not going to look very good. I would have put some flowers mixed in with the berries and vegetables, made it spruced up a little bit, make things nice, guys. Anyway, one of the things that a lot of people always ask are, hey, I don't see another number. I need a number. They gave it to you when they said carrots, onions, peppers, tomatoes, because that's what's being planted. And they said they're sectioning off each part with that. So that's your value. People's names, they matter, things like that. Anything you can measure. So I know I'm going to need 4 equal parts because I have carrots, onions, peppers, and tomatoes. So 1, 2, 3, 4. And then I have carrots, onions, peppers, tomatoes. So what do I know here? Well, I know that I have 4 plants that need to be divided into thirds. Nope, screwed that up. This is what happens when you do things at 11 o'clock at night, kids. Apologies. But at least you realize it's wrong. Remember, mistakes are totally cool to make, as long as we catch them or learn from them. So what do I have? I have a third, all right? I have a third of these vegetables. This is the third of the garden right here. And what am I doing to it? I'm sectioning it into 4 pieces. See, it's all about how you set it up. Because now when I do the math, my what I'm going to start with stays the same. I take the inverse operation of division, which is multiplication, and the reciprocal. So instead of dividing it into 4 sections, I want to know what one of those sections equals out of the whole garden. And it's going to be 1/12. And if I look here at my carrots, because that's what they wanted, I can see clearly that it's 1 out of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The other way, I would have ended up getting 12, which would have been like 12 gardens, which is not a good thing, all right? Or 12 sections. That's more likely, 12 sections. And no one's planting 12 sections of carrots, otherwise your whole garden is carrots. And that's just silly. Unless you're a bunny, because I have a feeling that bunnies would probably like that. But then again, bunnies don't really make their own gardens, do they? No. Not unless you're in Zootopia. Anyway, a utility company is planning to install wind turbines on 4 square miles of land. Okay? I already know what I have. I have 4 square miles of land. I'm not going to draw a rectangle. I'm going to draw a square. Because I went to kindergarten and I learned my shapes. Because even words like square matter in a problem, guys. So I have 4 square miles. So, boom. That's 4 square miles. Each turbine requires 1/6 of a square mile. So, what's that saying? Well, each turbine needs 1/6, right? That means that pretty much I can fit 6 turbines on there. So what do I have here? I have 4 square miles. And what am I dividing it by? I'm dividing each one into sixths because I'm going to be able to fit 6 on. How do you know that, Mr. O? Because when I take the reciprocal, that says, hey, I can fit 6 turbines in 1 acre. And let's do this. I'm going to try to do this without the stylus neat. So now, if you look, in each section I have 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Repeat what I just said right here. All right, so what am I going to have total? How many turbines can I install on the entire 4 acres? Because that's what they care about. Well, I would do each one. I have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. It's an array. 6 times 4, 24. I can put 24 turbines on these 4 acres. And if you look, we said that there were going to be 6 and 1, right? So I have 1, 2, 3, 4, 5, 6, and 4 identical sections. So 6 times 4. There are so many different ways you can figure out your 6 times 4. I mean, heck, we could even go 1, 2, 3, 4, and then say I have 6 rows of it, right? Which is pretty much what I did first. Should have went down instead. Said 4, whatever. When you divide a whole number by a fraction less than 1, will the quotient be greater or less than the whole number? Now, these questions, they come up a lot. You don't have to just know the answer off the top of your head all the time. Sometimes you might want to sit and think about it. I still draw the equation first, just so that way I can look at it to make sure what I'm looking at matches the words. And I'm going to do it right now too, because that's what smart people do. They show their work. When you divide a whole number by a fraction, so I'm going to pick any whole number, and you know that I like to pick 2, because 2 always works beautifully. By a fraction less than 1, pick a half. It's always good to pick a half, because if you're working with 2 and you're working with half, you know half of 2 is 1. All right, will the quotient be greater or less than the whole number? Well, when I do this problem, I'm going to do the reciprocal. I would get 4. Now, they want to compare it to the whole number I started with. Well, this 4 is greater than this 2. All right, so I could say that it's greater. Always make sure you compare to the number that they want you to. 4 square miles of land is separated into sections that each have an area of half a square mile. How many sections are there? So I have, once again, I have 4 square miles that I'm dividing into half. So each one of those is 1 for a total of 4. Divide them each in half. And there you go. How many sections do I have? I can count it. 1, 2, 3, 4, 5, 6, 7, 8. All right. I could do the algorithm if I wanted. 4 times the reciprocal. It's 8. The other thing I wanted to make sure that you knew was, you saw that I cut those vertically, right? It doesn't matter how you cut them as long as you cut them in half. You're still going to get 8. Still going to get 8. All right, last bit. I want to talk about number lines, okay? When we get over here, one of the things that we're going to notice is that these problems are similar, but not the same. Here, this is saying I have 5, and I'm dividing it in half. So if I do the number line, I would start with 0, and I would draw all 5. Then it's saying, hey, you're cutting each in half. And I did. So now we can count how many sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you did the algorithm, you're going to get 5 times the reciprocal. Boom. So what they're saying is you have 5 pizzas. You're cutting each in half. How many pieces does that make? It makes 10 pieces. Over here, I have half. I don't even have 1. And I want to divide that into fifths. Now remember one thing. We're talking about unit fractions, right? So we always need to relate it to a whole. Because you might say, well, I'm going to stop at half, but you can't. You have to go to the whole. So each section should be in each half should be in 5 sections. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. Now, even though I have half, I need to figure out what its relationship is to 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So a denominator is always telling you how many pieces you have, and the unit fraction is one of them. So one of those sections is 1/10. If I take a half and I divide it by 5, I'm going to get 1, 2, 3, 4, 5. The unit rate for one of those is 1/10, because I have to relate it here. And you'll see that a lot more clear when I take the problem, I take the half, I do the inverse operation, and whoops, I wrote that in the wrong spot. Did I mention it's like after 11? I take the reciprocal of 5, which is 1/5, and that equals 1/10. And the reason being is we're saying, hey, 5 pieces in the half, so each one's a fifth, but I have 2 halves to make the whole. So 5 times 2, 10. All right, 6 divided by 1/3. So I'm taking these 6 squares, I'm dividing them into thirds. If you count them, what are you going to get? 18, because 6 times 3 is 18. Now over here, it's saying that I have a third divided by 6. And this is going to be really hard to do. Let me see if this will work. I'm sorry, give me 1 second. Oh, yeah. So sorry about all the other writing, but let's go here. So 1/3 divided into sixths. So I'm going to divide everything into sixths. 1, 2, 3, 4, 5. Okay, that's 6. But I'm only really concerned in the end with this area, the 1/3 of the whole. It's still all out of the whole, though, for the unit fraction. So what do I have? Well, I have... I'm only caring about what the unit is. It's one of these. What is 1/3 divided by 6? It's this, because here's 1, 2, 3, 4, 5, 6 of 1/3, right? So what's the unit? What's 1? It's this. What is this 1 bar? Well, it's 1/18th, because 6 would become 1/6. And there you go. That's what's happening. So, I hope you enjoyed this. Sorry it's super late. Life gets in the way. I apologize, but hopefully this will help you for your test next week. Get ready, guys. Take care. Bye-bye.